So hello, today we'll be starting with transients. So first point in transient is identification of model. Proper model identification is very much necessary. Now what I mean by model identification, let me give a brief hint about it. So there are models like source free, model 1. Model 2 is where you are asked initial values, final values or d by di by dt of I0 plus something like that. Specific instances 0 plus 0 minus is related either difference, di by dt, dc by dt or initial values, or else the model number 3 is total response, source is there, final value plus initial value minus final value, and finally model number 4, that is Laplace. Okay, these are the models which we'll be talking. That's one thing. Then there are questions on energy calculations, very important. There also we have two models, so there also model identification is necessary. So basically in this whole chapter, majorly this first out of first four model, you have to identify which model it belongs to, and if it is energy asked questions, then there are two models with respect to that. We shall check in what all are there. Fine, but before that let's understand what are the equivalent circuit of that. Now at the t0 minus, let's say assuming inductor is getting charged for a very long time at t so at what happens is at t0 minus, it will steady state, right? Steady state. So at t0 minus, inductor will short circuit assuming it is charging for a very long time, and capacitor will open circuit. This is at t is equals to 0 minus. At t is equals to 0 plus, inductor will act as open circuit. Okay, open circuit, but its property of not changing current will not change, right? So what we'll do is we'll replace it by a current source, and at t is equals to 0 plus, and volt current and capacitor would be open circuited, right? Open circuited, that's okay. But what about the voltage at the t0 minus? So that will be coming as vc 0. Okay, now as I told that it cannot inductor and capacitor cannot change its property, so IL0 plus will be equals to IL0 minus, and VL0 plus is equals to VL0 minus. This is at t is equals to 0 plus, so it is short, capacitor is short, but there is some voltage across it. Inductor is open, but the current which was there at t is equals to 0 minus still pertains. The equivalent diagram for that is, as I told, it would be something like inductor parallel with the current source, and VC in parallel with the capacitor. Okay, now quickly let's look at the models. As I told, there will be four models, so identification of model is very important. If it is a source free circuit, meaning there is no source at t is equals to, after switching at t is equals to 0 plus, no source is there at that point, v1 is nothing but across capacitor v0 e की power minus t by tau, and il will be I0 e की power minus t by tau. Now if the questions are specifically asked on initial values, in that case what we will be doing, we shall look, circuit becomes purely resistive. Very important point, circuit becomes very much purely resistive. In that case we should be checking dil upon dt at I is equals to 0 plus, and dvc upon dt at I is equals to 0 plus. Now we know LDI by dt is nothing but VL, so we should be finding VL upon L at 0 plus. Similarly for VC, IC of 0 plus upon C. Okay, very important this model is. Usually you write change of voltage, change of current to be 0, but when it is 0 plus, in that case never forget to take V by L or IC upon C. Okay, very important model this is. Then next comes with responses, then final value plus initial value minus final value e की power minus t by tau, that's the total response. Now what about if nothing strikes? Model number 4. If nothing strikes, simply we'll do Laplace. For second order we'll do Laplace. Fine. Now let's quickly move ahead. The current can be of different forms. It can be exponential, linear, instantaneous, charge. Similarly, voltage in inductor circuit can be of different forms. Now let's say if current is exponential, meaning normal RC circuit. For linear, if current is a constant source, in that case VC will be linear. For suddenly changing, where KVL violates, okay, let's say V and C parallel with some initial charging, in that case there will be something like del T. Okay, this linear charging is also very important. Linear charging meaning when the constant current source is there in RC circuit, in capacitive circuit. But what if a voltage source is there in inductor circuit? In that case there will be linear charging as well for inductive circuit. Then there is some current source and an inductor where you have to charge it instantaneously. In that case some delta impulsive response will exist. Now what if del T is the input is del T? At that case IL plus 0 plus is not equals to IL 0 minus, and VC 0 plus is not equals to VC 0 minus, and EL of 0 plus is nothing but 1 upon 2L, and EC of 0 plus is nothing but 1 upon 2C. Fine. Now coming to model number 3, then coming to the model of capacitors. So energy across capacitor, two models are there. There is some initial voltage across capacitor, no initial voltage across capacitor. Initial voltage across capacitor is 0, let's say. For RC series circuit only, okay, initial capacitance is 0, meaning what? ER at infinity is equals to EC at infinity, that is half C V square, and total is nothing but ER plus EC, that is nothing but C V square into at infinity. This is valid only for, this is very important property, you'll get many questions from this. So this is valid only for series RC circuit with initial VC, that is VC 0 plus is equals to 0. Very important. Now an example with respect to that is what? Initial charge is, let's say 1 farad is 0, so that is VC 0 is 0, and energy in zone, so that is nothing but model 1, case 1. Okay, steady state is reached, transferred from DC source is ER plus EC, that is half CV square into 2, so CV square will be the answer, CVC infinity. Fine, you can check. Then comes the energy dissipated until, so again energy dissipation question, but VC is not 0. In that case there will be two approaches. One thing is you will find out E final minus initial normal half CV square 1 minus half CVT square and so on. But if KVL is violated, in that case we'll be moving to Laplace. Okay, so here there is no KVL violation, nothing. In this case what we'll find out initial half CV1 square plus half CV2 square, then final half CV square, and then we'll subtract and we'll get energy across resistor. Now determine the energy supplied by 1 volt source connected across capacitor. Here definitely there is a KVL violation. In that case what we'll do, this is case 2, VC 0 minus is not 0, and also it says initial capacitor's voltage is minus 1, so VC 0 minus is not 0 first of all, and the second thing is VC 0 minus is not 0, and also KVL is getting violated. So chupchap se we will apply Laplace theorem, and we will be getting the solution. Okay. Then one of the questions is there, in the circuit shown S2 is closed after a long time at t is equals to 0 plus, so clearly it is nothing but model 2. It is asked at t is equals to the rate of change of current, definitely di by dt at t is equals to 0 plus, you will find out nothing but VL upon L at 0 plus, simply nothing more. Then very last question, we are asked to find the range of IT. This is a second order equation system. Second order mane, this is nothing but model number 4. What we will be doing is nothing but Laplace. We will be finding IT and VT. Okay, very simple. With this we can stop this lecture. Thank you. Just to revise, there are 4 models. First is nothing but source free. Second is at 0 t is equals to 0 plus dl upon dt dvc upon dt. Next one is initial value final value plus initial value minus final value k per minus t by term, and fourth one is Laplace. In energy also there are two models, vc of 0 plus and vc of 0. Vc 0 is equals to 0, vc 0 is not 0. Vc of 0 is 0, then model is very simple. Er equals to ec at infinity, that is equals to half cv square, and es is equals to er plus ec. But if it is not 0, vc is not 0, in that case there will be two models. If everything is proper, then we'll do initial minus final energy. But if it is a second order system or KVL is getting violated, in that case we will be doing straight away Laplace. Fine. With that we can stop this lecture. Thank you.